All right, guys, we're on to test one, section 3. Number 1, we're going to start here. It's here's the equation that they're giving you on number 1, and they're telling you that k equals 3, which is probably pretty nice of them since we have two variables here. And they just want you to solve this for x. So in this case, we're just going to, it's number 1. It's an easy question, so it's pretty straightforward. You do exactly what they say. So that means take this 3 and plug it in here for x. So we're going to, or plug it in for k. So we're going to have x minus 1 over 3 equals 3. Now you do have the option here of taking the answers and just plugging them into the equation to see which one works. So if you ever get stuck on what you should do next, that is an option to work backwards. In this case, I'm just going to go ahead and solve it algebraically, which means I'm going to multiply both sides by 3. So those are going to cancel out over there. And you're going to get x minus 1 equals 9. And lastly, we're just going to add 1 to both sides, and you get x equals 10. In this case, 10 is going to be D. So number 1 is D. Moving on to number 2. Number 2, they just want you to simplify this. They are letting you know that I is the square root of negative 1. Whereas in this problem, it really doesn't mean anything. Think of it like unlike terms. And you're just combining like terms. So the i's are like terms and the constants are like terms. Again, it's number 2, so they're not doing anything too crazy here. So what we're going to want to do, first off, you would think of maybe distributing that plus sign, but that doesn't really do anything. So in essence, this parentheses here is just there to throw you off. It's really doing nothing. So if you wanted to rewrite this, you can do that as 7 plus 3i minus, well, I have the minus up there a little bit, but minus 8, because plus a negative, and then plus 9i. So once you've done that and you don't have to worry about the parentheses anymore, you have your constants, which are like terms, and you have your imaginary numbers, which are like terms. 7 minus 8 is negative 1. 3 plus 9 is 12i. So negative 1 plus 12i is going to be A. So number 2 is A. Next up, we have number 3, which really I don't have much written because it's a very long, wordy problem. But there are certain words that you want to pay attention to. So this one is, I'm just reading it down here. It says on Saturday afternoon, Armand sent M text messages each hour. Now I want to make a note when you see the word each, I want you to think, I can spell that correctly, I want you to think multiply. That's one. Also, you can call it a rate. That's dealing with rates because you're doing something every single hour, so it's going to do it multiple times. And that's a good rate or slope scenario when you're going to see those words. So he sent M text messages each hour for 5 hours. So that's telling me that I'm going to have a rate of 5. So this is telling me at this point that I have somewhere a 5M. Each hour tells me I'm multiplying, and they're telling me we have M for the text messages and 5 for the hours. So to figure out how many he sent, 5 times M would give you that total. And Tyrone sent P text messages each hour for 4 hours. So really dealing with the same thing here. So we're going to have the next one for our rate. We have 4 times P. So those are our 2 rates that we have in this problem. So which of the following represents the total number of messages? So we just want to figure out how many you have in total. Well, all we got to do is add those up. And again, this word right here is a very common SAT word. I want you to remember that. So in this case, that's going to be C when you add them up, and that's number 3. So moving on to number 4, another fairly wordy problem, but they're giving you this equation. Now one thing before I even start reading this question, when you see this equation, there's 2 things that need to really stand out. This value right here, which is a y-intercept, but in terms of the SAT and an application-wise, this is going to be represented as a starting point. So they may mention it as like an initial value or something like that, somewhere where you begin. Okay, so an initial value, a starting point. they don't normally say the word y-intercept, but it's where you start. And then this value right here is a rate. And just like the problem before it, you want to look for words such as each or per. Something that happens each month, or you're getting charged this amount per month. So those words are words that you should be paying attention to and understanding what they represent. So in this problem, we want to know what the D is and what the P is and all those things so we understand what's going on. So this one is about Kathy. She's a repair technician. She receives a batch of phones that she needs to repair. Now the number of phones that she has left to fix at the end of each day can be estimated with this equation. So this tells you as an output how many phones. So I'm going to kind of put that right in there. P is the number of phones left. So we have phones left to repair. And this is all given to you. You just highlighted in your question. D is the number of days. So D is the number of days. So if you wanted to kind of analyze this situation, what it looks like, you have initially 108 phones to repair. You are repairing 23 phones per day. So you can kind of take those numbers and use the variables and you can figure out what this represents. So we initially had 108 phones. We are repairing, because that number is going down, 23 per day. So this is telling us how many we have left to repair. So at this point, they say, what is the meaning of the 108? As soon as you see that, okay, this 108, this is the initial value. So in this case, I'll say the initial phones to repair. Because this is, now we're able to figure out this other little piece in here. So when you look at that, B is going to state that Kathy starts each week with 108 phones to fix. So that's going to represent answer choice B. So that's going to be number 4. Moving on to number 5. Number 5 is just giving you that expression. They want you to simplify it. Now, unlike number 2, where I talked about that distributing a positive and how it doesn't change anything, we're starting to get to some of the harder ones. And again, we're not anything crazy yet, but they are going to start getting harder. And now you'll see we have a minus sign. So this minus sign, I'm just going to move down here so you can see it a little bit better. I was just running out of room when I wrote it. This minus sign needs to get distributed. Just like I technically distributed the plus sign, this though it changes things. Because when you distribute a negative, all those signs are going to switch. So now you're going to have x squared y minus 3y squared plus 5x y squared. Now that doesn't really change anything. However, this becomes a plus x squared y. This becomes a minus. That's a y, by the way. This becomes a minus 3xy squared and a plus, I'm running out of room, so plus 3y squared. All those signs switched. That's really obviously important to notice here, because if you don't do that, well, you're not going to be getting this. But now we want to just combine like terms. So you'll see I have x squared y. I don't have any x squared y's anywhere else, so I'm going to just go ahead and go there. Stop here. So the 3y squared, you'll notice here and here, those are going to cancel out, so I don't have to worry about those. I have my 5xy squared and 3xy squared. So I have these two that will also combine. So starting with my x squared y's, I have 2x squared y. And I have 5 minus 3, so plus 2xy squared. So you want to find the answer that matches that, and that's going to be C. And next up, finally, we have number 6. So number 6, they are just giving us that equation. And again, a very similar equation. Remember, we have an initial value, and we have a rate. So in this case, they want to know, they're giving us this equation. They're telling you it's a pediatrician uses this model to estimate the height of a boy in inches in terms of the boy's age A. So we have height in terms of age. So this is how old they are. This is their height. So obviously they get taller. They have an initial height of 28.6 inches, and then they start growing by, I guess, 3 inches each year, looks like what they're saying here. So, and this obviously only counts between the ages of 2 and 5, but that doesn't matter in this case because the question that they're asking is what is the estimated increase? So we're talking about an increase. This should take you right here. Well, that's what a rate is. It's an increase or a decrease, but in this case it's an increase. It's positive. So what is the estimated increase in inches of a boy's height each year? Now remember that word each, because again, that kind of gives this away. We're talking about the rate. So as soon as I see that, bam, A, my answer, because remember A is equal to 3. So as soon as you see that, you know that's what they're asking for. They're just their fancy way of asking for the slope, which is the rate of change. So that's going to be number 6.